Okay, today we're going to start talking about section 4.6, which we've graphed sine and cosine functions, and we've graphed them based upon horizontal and vertical shifts, as well as period and amplitude changes, okay? So now we're going to graph the other 4 remaining trig functions. And if you can graph sine and cosine, then you automatically can graph secant and cosecant. Everything is exactly the same, except for your levels turn into asymptotes, and you reflect your parabolas, and I'll show you that here in a second. However, tangent and cotangent have a different period than what sine and cosine do. So we have a little bit of tweaks on that one. So the very first thing your brain needs to understand is that we're graphing the 4 remaining trig functions. Cosecant is the reciprocal of sine. Secant is the reciprocal of cosine, something we already know that, okay? To graph a cosecant or secant graph, you must graph its inverse first, or its reciprocal function. You have to graph its reciprocal function first. Okay, which is sine of x or cosine of x respectively. Every level turns into an asymptote. An asymptote is a dotted line, right? And it's like a boundary line. It gets super, super close to it, but it never crosses it, okay? And then you're going to reflect your max and min in parabolas over the arms, okay? So these 2 pages are super important for you to understand. Cosecant still has a period of 2 pi. The starting point is still equal to 0. The ending point is still equal to 2 pi. The normal cycle is between 0 and 2 pi, which is why we are utilizing 0 and 2 pi. So we're doing everything that we've done previously. Now, the graph of cosecant, you have to graph sine. So you are going to graph your sine function first. But then you are going to take every level and turn it into an asymptote. And then the maximum becomes the minimum of a parabola, and you're going to go up with it. The level is still an asymptote, and then the minimum becomes a maximum, and it is going to go down, and you're going to reflect it, and then you're going to have an asymptote. That is the cosecant. The secant graph, period is still going to be 2 pi, still 0 to 2 pi, still starting point equal to 2 pi, still ending point equal to 2 pi, okay? Now, what is different is that the cosine graph, just as the secant graph, you have to graph cosine in order to graph secant, and then all of your levels turn into asymptotes, and all of your maxes become an arm, and then your minimum becomes a maximum, and it's going to be a parabola. So let's go ahead and jump into those so that you guys understand what I am talking about. So, in order for me to graph this function, what my brain needs to understand I need to graph is actually y equals -2 times the cosine of 4x plus 2. You cannot graph the secant until you graph the cosine. Okay, so immediately I'm going to change this problem, and I'm going to go to town on this problem just like we did before. My amplitude is the absolute value of -2, which is 2. Because it is negative, that means my pattern is flipped. Normally, cosine is the handlebar graph, but because it's flipped, it now is going to come down here at the bottom. So this is going to be a minimum, a level, a maximum, a level, a minimum. You have to remember that, okay? Which means the next thing I'm going to do is find the period. The period is going to be 2 pi divided by my absolute value of b. b is right here attached by multiplication, so that's going to be 2 pi divided by 4, which is pi over 2. Now, question, is it taking longer, or and I'm resting, or is it taking a shorter amount of time and I'm running? Okay, well that means you're going to compare this to 2 pi, and when I compare that it's less than, so I am faster. I'm completing 1 revolution faster because pi over 2 is smaller than that. Okay, so from there I need to find my period or my interval. My interval is going to be my period divided by 4. So my period is pi over 2. If I'm dividing by 4, I'm multiplying by 4 to give me pi over 8. Okay, so the next thing is I need to go ahead and find my, I'm going to come back over here and do that here. I need to find my level. My level is 0 plus or minus c. c is going to be by 2, so that's going to be 0 plus 2, which gives me 2 as my level, which means my maximum is going to be my level plus my amp, so that's going to be 2 plus a 2, which gives me a 4 as my maximum. And then my minimum is going to be my level minus my amp, so that's going to be 2 minus 4, which gives me negative 2 as my minimum. Okay? So I found everything I typically would find for sine and cosine, but now I need to find my starting point and my ending point. Well, how do I know I need to find my starting point and my ending point? Because I have parentheses, but am I adding anything in my parentheses? The answer to that is no, but let's say you didn't remember that. So if you didn't remember that, all that means is you're just going to take an extra step to confirm that you did not mess up. So 4x is equal to 0, so x is equal to 0. And then my ending point is going to be 4x is equal to 2 pi, so x is equal to pi over 2. And if you look at your period, this is your period, which means I know that I'm right. Because if I check this, my period is my starting point minus my ending point. So that's 0 minus pi over 2, which is negative pi over 2, which is just pi over 2. So I know I'm right. Okay? I didn't need to do this step because I wasn't adding or subtracting anything in the parentheses. But it's a good thing to constantly stay in the routine and do the same thing over and over again. Okay, so now with that being said, I need to go ahead and do my XY table. So if I'm doing my XY table, now this is where things get a little bit shaky. I need to graph the cosine, not the secant. My pattern, then I have my y values, and then I have my secant graph, okay? I have my secant graph that I'm going to graph at the end. Okay, I said I was starting at 0, and my interval that I'm adding is going to be pi over 8. So this is going to be pi over 8. Pi over 8 plus pi over 8 is 2 pi over 8. 2 pi over 8 reduces down to pi over 4. This is going to be 3 pi over 8. And then 4 pi over 8 reduces down to be pi over 2. So I have all 5 of my points there. And at this point, I'm going to fill in my pattern. We said that it's going to be opposite. So my pattern is going to be a minimum, a level, a maximum, a level, and a minimum. Okay? So we're going to go ahead and do some calculations to make sure that we did not mess up. 4 times 0 is 0. The cosine at 0, well, if we go ahead and do 1, 0, 0, 1, negative 1, 0, and 0, negative 1, the cosine at 0 is going to be 1. So this is going to be negative 2 times 1, which is negative 2, plus 2, which is going to give me a 0. Is that... Whoa. Time out. Let me back up here. The cosine at 0 is 1. 1 times negative 2 is negative 2. Plus 2 is going to give me a 0, which means, hold on 1 second. Okay, we messed up on our minimum here. I went a little fast there, and I put a 4 here, and that should not be a 4. See how that nice check can help us to be able to determine where our mistakes are? So 2 minus 2 gives me a 0, and that is your minimum value, which means I am right, and my pattern is right so far. See, sometimes you just have to take a seat and check again. So let's go again. Negative 2 times the cosine of 4 times pi over 8 plus 2. This becomes pi over 2. The cosine at pi over 2 is going to be 0. So this is going to be the cosine of 0 times negative 2 is going to give me a 0 plus 2 is going to give me a 2. And that should be my level, which it is. So I know that I'm right on there. So I'm going to go ahead and do the next one here. The next one is going to be negative 2 times the cosine of 4 times pi over 4. So those cancel out to give me pi. And what is the cosine at pi? That's going to be negative 1. So that's negative 2 times negative 1, which gives me a 2 plus 2, which is a 4. And that is going to be our maximum. So I'm really hoping that you all found this mistake that I had on there earlier. It's okay. I know that our pattern is right, so this can turn into a 2, and this can turn into a 0. So if I graph this, I'm going to be having 1, 2, 3, 4, 1, 2, 3, 4, and I'm going to be at 0, pi over 8, pi over 4, 3 pi over 8, and pi over 2. Okay? So, if I graph this at 0, I'm at 0. At pi over 8, I'm at 2. At pi over 4, I'm at 4. At 3 pi over 8, I'm going to be at 2. And at pi over 2, I'm at 0. So this is what the graph looks like. Now, we have to graph the secant graph. I said that all of your levels turn into asymptotes. So that means I have a dotted line here and a dotted line here. Then I said that these value of the 4 and the 0 are going to stay the same, but they are going to turn into parabolas. So I'm literally going to draw a parabola for only what it is. So I'm reflecting the purple graph, and what I actually need are the red. So this purple part right here now is a reflection, and it goes up. This purple arm right here, is reflected down. This purple arm right here is reflected down, and this purple part right here is reflected up. That is the secant graph. So the levels turn to asymptotes, and you just carry over these numbers right here. And that is the secant graph. Okay? Then I have tangent and cotangent graphs that we're going to talk about. My tangent graph is going to be exactly the same, except for now my period is going to be pi units, and I'm starting at negative pi over 2 to pi over 2. So I set the starting point equal to negative pi over 2, and the ending is equal to positive pi over 2. The pattern is an increasing function. It looks like an x cubed function. It looks like an x cubed function. Okay? It's going to look like this. But we're going to have a starting point, and our ending point are always going to be asymptotes. This is your starting point. This is your ending point. And then you're going to have a low, middle, high. You can't have a max, level, min. You're going to have a low, middle, high. It's still the same process. The low point's here, the middle is here, and then the high is right here. That is your tangent graph. Your cotangent graph is going to be very similar, but it is a decreasing function, but it has a starting point at 0 and ends at pi, and it is going to be a decreasing function like this. So you're going to still have your high, middle, and your low. Starting point is going to be an asymptote, and your ending point is an asymptote, and you still have high, middle, low. Tonight's homework is going to be tangent, secant, cosecant, trig functions, and I'm going to do a tangent function for you now.